Hello folks, we are taking the part 8 video of the exercise 3.3. We have finished till the 19th problem, now it is the 20th problem. So let's continue and see how we are able to do it. Again we are given things on the board, we just have to use a correct identity and then solve it. The numerator, the identity seems to be sin A minus sin B. So let's have a look at it. Sin A minus sin B, we all know is 2 cos A plus B by 2 into sin A minus B by 2. So we are going to apply that. We are first going to consider the LHS. And in the LHS, we have sin x minus sin 2x, where we are applying this identity. It is 2 times cos. First, we will write the sum. So x plus 3x by 2 and sin x minus 3x by 2. Now, denominator, with bit of foresight, what we do is, instead of writing cos squared x minus sin squared x minus cos squared x, there is no harm if I write it as minus cos squared x minus sin squared x. Idea is the same, value is the same, but it helps us. Like if you just open up and see minus cos squared x minus cos squared x, minus into minus plus sin squared x plus sin squared x. We have not changed the value, but we have written it in a convenient form. So let's see now how you can solve this. The numerator is 2, 4x by 2, so it's cos 2x. And this is sin minus x minus 2x is minus 2x by 2, so it's minus x by, minus is there over here, cos squared x minus sin squared x is cos 2x. We have learnt it in the cos 2x formula, that cos 2x is, it has got many formula, out of which one is cos squared x minus sin squared x. So instead of writing that, there's no harm if I write cos 2x. What's the advantage? We can have this cut. Now, we have also learnt earlier that sine of minus theta is sin theta. So that way, we get this out. It is 2 into minus sin theta. Why? Sin x. Why? Because we have learned that sine of minus theta is minus sin theta. So like that, you have that gone out, and here only one is left because the other things have got cut. So the minuses can cut each other. You get the answer as 2 sin x, which is the RHS, and that's how we prove our result. Hence proved. So that's how we get across doing this particular problem. Now let's move to the next problem. Now in the next problem, earlier also we have seen somewhere 3 terms coming. We have got 3 terms both in the numerator and in the denominator. So generally this goes by and large by observation. You have to club terms, apply the formula, get the answer. But how should you club? Now there's no hard and fast rule, but generally whenever there are 3 terms, the biggest and the smallest, when you club it together, generally it works, right? So we'll also apply that same logic. Of course, there are other ways. As you keep practicing, you get to know how you can club things together. But this is a very rough, vague way of doing it. Let's do that and let's see if it's working. So what we do is, to start with, the biggest and the smallest term we will club. We will club these two, we'll club these two. And we'll be therefore applying the cos formula and sin formula. Cos A plus cos B will come to 2 cos A plus B by 2 cos A minus B by 2, and sin A plus sin B will work to 2 sin A plus B by 2 cos A minus B by 2. Okay, let's quickly apply it and see what comes. We have to first consider the LHS, and there we have clubbed the terms, and that works out to cos 4x plus 2x by 2 cos 4x minus 2x by 2 and plus cos 3x. Denominator, you have 2 sin 4x plus 2x by 2 and cos 4x minus 2x by 2 and sin 3x. So let's see now how this simplifies. 4x plus 2x, it's 6x, 6x by 2, it's 3x. So it's cos 3x. And cos 2x by 2, so that's x, plus cos 3x. And here also it is 2 sin 3x cos x plus sin 3x. So you have, if you carefully observe, in the numerator you have this cos 3x common and you have the sin 3x common. So let's take it out. that cos 3x, when you take it out common, you're left with 2 cos x in the first group, and in the second group 1 remaining. Right? We have taken things common. We have taken cos 3x common in the numerator. Now what do we do in the denominator? We try to take the sin 3x out and see what happens. If we take the sin 3x out, in the first bracket you're left with the 2 cos x. First group you're left with 2 cos x, and the second group nothing is there, so 1 is there. So we have taken these things common. Now incidentally, it so happens that 2 cos x plus 1, 2 cos x plus 1 is occurring both in the numerator and denominator. That allows you to cancel them. So let's cancel. So what we are left with? Cos 3x by sin 3x. That is very well cot 3x. So you are done with your work. It is cot 3x, which is also our RHS, and that is how we prove our result. Hence proved. That's about it. Now, having done this, let's quickly move to the next question. It looks a little weird. Cot x into cot 2x minus cot 2x into cot 3x minus cot 3x into cot x equal to 1. Now, these problems alone, there is a similar problem in tan also, where you have tan x, x2x, x3x, that kind of combination in tan. There also you have to apply the same strategy. We don't start with anything as such. We will start with 3x equal to x plus 2x, and we work out and we come to this result. That's how we do it. That's probably the better way of doing these kind of problems. As I said, for cot and tan alone, these kind of problems can be done by that strategy. Works well, works a little comfortably. So for that, let's consider no LHS RHS business, but we are considering 3x equal to 2x plus x. We know 3x is 2x plus x, so no harm in considering like that. Now since we are more interested in cot, we will apply cot on both sides. So what we are doing? We are applying cot on both sides. So we have cot of 2x plus x. So at this stage, we will apply the cot formula, cot a plus b. What's the formula? Are we recollecting? Cot a plus b formula says it is cot a cot b minus 1 by cot a plus cot b. If you could give me a second's time, I will just have a quick look. Yeah, just confirm. Yeah, it's confirmed and great. Now let's move. So we have cot 2x cot x minus 1 by cot 2x plus cot x. We have just applied the formula which we have written in the adjoining bracket. Okay, so what have we got? We have got cot 3x equal to cot 2x cot x minus 1 by cot 2x plus cot x. We plan to take this term on the other side. Okay, it gets multiplied to the other side. So we get like cot 3x times cot 2x plus cot x. And on this side, you have cot 2x cot x minus 1. How does this open? It opens like cot 3x into cot 2x plus cot 3x into cot x, becoming equal to cot 2x into cot x minus 1. Now what we do is, because we want something equal to 1, that will give you a prompt that why not take this 1 on the other side and bring other terms from on this side. That works better. So let's push this 1 on this side, and these two terms, let it come on this side. So they will come with the change of signs. So minus 1 will go on that side and it will become 1, and this term is already there here, that is cot 2x cot x is already there, so it will stay as it is. These are both positive terms, they come to the next side, they become negative. So you get cot 2x into cot 3x minus cot 3x into cot x, and it's exactly what you need to show over there, and you have proved the result, hence proved. So this is a different way of proving it. It's always not necessary that you start with the LHS, get the LHS, start with the LHS, get the LHS, not necessary. You take any mathematical fact and with the help of that fact you prove a particular statement, that's also fair enough, and that's what we have done over here. So this is our problem number 22. The remaining problems we'll probably take it up in the next video. Thank you.